Anybody? Okay. So the topic we will be seeing for this section is divide and conquer method. The contents of this section are divide and conquer method, the approach used for divide and conquer method, and an example of a divide and conquer method, which is a matrix multiplication. So this we will be seeing the base like a overview of the divide and conquer method. Divide and conquer method is the strategy which is used for solving the difficult problems. In order to solve those difficult problems, the original problem is segregated or divided into several subproblems. Then it is solved one by one, and finally it is combined in order to produce the original solution. So there are three approaches in this divide and conquer method. One is divide or break. The second one is conquer or solve. Third one is the final part, merge or combine. In this divided part, the original problem is divided into several small subproblems. These subproblems must represent the part of the original problem so that it is not going away from the original logic of the problem. Like if you are taking any max the related problems, if we are doing this max addition or multiplication, anything, the subproblems must be related to those operations, and it must not deviate from the original problem. In order to segregate this original problem into several subproblems, recursive approach is followed, where the original problem is recursively divided into several subproblems until a stage comes where that problem can't be divided further. So every subproblems became atomic in nature, whereas it represents some part of the actual problem. So we have divided the problems into several problems. Then we have to solve them. Conquer is nothing, just solving those subproblems based on the type of the problem we have taken. Then the final part is merge or combine. This is the solving the problem, solving the smaller subproblems recursively, and then this is solving. This is after solving this subproblems recursively. These solutions are combined, and final solution is obtained. So you would have seen these three techniques. These are the computer algorithms that are based on divide and conquer programming approach. Merge, quick sort, and binary search you would have seen. For this section, we will be seeing this Hello? I think somebody's mic is unmuted. Okay.
Muted him.
So today, for this section, we will be seeing the Okay, no problem. Strasson's matrix multiplication. Just for a simple example, we will see the factorial problem, which we solve using the divide and conquer strategy. The normal formula for this factorial is n factorial is equal to n into n minus 1 into n minus 2. Like that it will go. If n is equal to 1, we will giving the same answer. Here, this is the problem. We will be dividing it into n minus 1, n minus 2. Then after that, so solving this n minus 1 and n minus 2, we will be again giving this solution to the multiply, so that n into n minus 1 into n minus 2 will be calculated, and final solution is given as the n factorial for the given number. So what we are doing here is dividing into subproblems. So first n minus 1 is calculated, then n minus 2 is calculated, then they are this solution is combined with combined and multiplied, and again the final solution is given. This is just an example, simple example. Recursion, we know that the same function is uh, carried out again and again based on the purpose of the problem. In case of n factorial, n cross n into n factorial of n minus 1. It will calculate the factorial of n minus 1 and multiply with n, and again it will be considered as the factorial of the given number. So this is just a overview of what is recursion and how recursion is used in the divide and conquer strategy. So coming into the matrix multiplication, this is a normal matrix multiplication which we will be doing manually. So consider a 2 cross 2 matrix. We will be solving by multiplying with this 1, taking 1 into 2 plus 3 into 6. The same we know about this. If we carried out the same method, we will be solving this matrix with the time complexity of O of n power 3. In case of divide and conquer method, we will be breaking this matrix into several submatrices. If we have the n cross n matrix, it will be divided by like n by 2 cross n by 2, which means 2 cross 2 will be divided into 2 by 2 into 2 by 2 means 1 cross 1 matrix. So this 1 will be taken as a separate matrix. Similarly, 3, 5 and 7, everything. And then this matrix will be multiplied with E, A and E, the B and G, C, E, D, G. Same operation only. It is similar only, but in case of programming, we will be considering this as the separate matrix. Divide them into single matrix here in case of 2 cross 2. Then after we will be doing the addition for this AE and BG, and finally we will be getting the output. If we take this example and consider solve this using manual method, this will be exactly same. But in case you are using the programming approach, in case you are going for the other n cross n matrices, in coding you will be considering them as the separate matrix based on this formula. Divide the n cross n matrix into n by 2 cross n by 2 matrix, and then solving them separately. Then combining these solutions, you will be getting the single matrix, which will be the answer for this matrix multiplication problem. Here in this method, the time complexity is same. It has 8 addition, 8 multiplications, AE, BG, AF, B into H, C into E, D into G, C into F, and D into H. 8 multiplication operations, and these matrices, the addition of these 2 multiplications, which will be considered as 4 additions. Here addition 1, 2, 3. So totally 8 multiplication operations and 4 additions. So here for addition of 2 matrices, it is O of n power 2 plus 8 multiplication. This is a complexity. When we add them, we will be getting the same complexity which we got in the normal method, which we will be doing using the hand. So in order to overcome this, in order to reduce the time complexity, we use the strassen method. So in this previous method, we are using the divide and conquer. 8 recursive calls were there. The 8 multiplication operation that was called 8 times in order to get the final solution. In case of stations, they are trying to reduce these number of recursive calls to 7. But the approach is similar to Durian contour method, where here also they will be dividing the matrix into several submatrices. Whereas this is considered this as the problem, and this problem is divided into subproblems. So matrix we are considering it as a problem and dividing it into submatrix, which is a subproblems, and finding the solution for these subproblems. So here this is a formula which is different from the normal matrix multiplication we are using. In this part, the submatrix, first we will be calculating the P5, P4, P2 and P6. For that we have the formula P5, which is the sum of A and D, and multiplied by sum of E and H. Similarly, it has other operations also, but here the number of operations we will be doing is 7. So the recursive calls is reduced from 8 to 7. Here from 8 to 7 we have reduced one call so that the time complexity can be reduced. If we take this same example and use the same formula, we will getting the same output, same matrix multiplication output, but the approach is different. In case of time complexity, the one operation is reduced, one recursive call is reduced. So it can be considered as the better in terms of time complexity. So taking the same problem based on these calculations, in calculating the P1, A into F minus H. So this will be the A, F and H 4. Similarly, if just we consider this P1 plus P2 and P3 plus P4 for these two, P1 is minus 4, P2 is 32. Final answer will be 28. So same 28. P3 and P4. P3 C plus D into E, which is 5 plus 7 into 2, which is a 24, and P4, which is D into G minus E. So 7 into 6 minus 2, which will be 28. 24 plus 28 is equal to 52. Similarly, every answer will be same, but the approach we are following is divide and conquer, and in that the formula we followed here is this one, and there by following this Jason's method, one recursive call is reduced when compared to the normal divide and conquer method, so that the time complexity is also reduced. So for in there we have a 8 multiplications, here 7. So when we calculate the time complexity of this Jason's method, we get the O of n power 2.8, where the previous normal divide conquer and normal matrix multiplication we got O of n power 3. So the time complexity is reduced. So regarding this Strasson's method, it is not preferred for practical applications, and it works. We can solve them easily by hand itself when we compare to this operation. But still, due to this time complexity, in case of programming and in case of machine-based calculations, we will be using this Strasson's method. These submatrices in recursion takes extra space, and it could give large errors in case of non-integer values when compared to the naive method, that is a normal matrix multiplication method. So up to this, if you guys have any doubt, just text the doubts if you guys have any. So no doubts. Shall I continue?
Sir, could you repeat, sir?
Repeat which strassen method or what? Hello.
No, sir, you asked, you can continue, sir. Yes, sir.
Okay, okay. So that's it regarding the divide and conquer method, which we will use for this matrix multiplication. So we will just see once again. So what we see in this section was divide and conquer method. In that divide and conquer method, the approaches this matrix multiplication. So what is divide and conquer method? Solving a difficult problem. In order to solve a difficult problem, we will be dividing them into several subproblems, solve these subproblems, and then finally combine them in order to get the final solution. Three approaches are there in divide and conquer. First step is divide it, break the problem into several subproblems, then solve these problems. First breaking we must do that recursively, so that the stage comes until the stage where we can't subdivide the divide the problem into other subproblems. Then solve it one by one based on the problem. Then combine these solutions and combine these solutions recursively and give the final solution. So these are the most popularly used algorithms in the divide and conquer approach. For a simple example is factorial, where this is the main problem. We break it into subproblem. So first n minus 1 is calculated, then n minus 2. Then based on these solutions, we will be again calculating, multiplying them, and finally we will get the factorial of the given number. Recursion, doing the same operation again and again based on the problem. Here in case of n factorial, factorial of n minus 1 into n, which will be again considered as the factorial of the given number. Normal matrix multiplication, which has the time complexity of O of n power 3. In case of divide and conquer, we will be dividing each matrix into submatrix based on this n by 2 cross n by 2. So this 2 cross 2 matrix here is considered as 1 cross 1 matrix. Each value here will be considered as a single matrix, and then that single matrix will be multiplied with other single matrix. A matrix is multiplied with E. Similarly, BG, AF, BH, these things. Then again, addition is done. Addition based on the AI and BG. So 4 operations are done, then final solution is obtained. So this is the example of when a divide and conquer method used in matrix multiplication. The answer will be same, but this approach will be considered in the programming part, where each matrix is divided into submatrix, and each submatrix is independently considered as a matrix, and the other operations are carried out. So regarding the time complexity, we have 8 multiplication operations and 4 addition operations, 1, 2, 3, 4, and multiplications 8. So A, E, B, G. So these 8 things. When calculating this time complexity, we will be getting the same O of n power 3. So in order to overcome this, we have to reduce the recursive calls. So in order to reduce the 8 recursive calls to 7, Strassen's method is used. This method follows the same dividing of the matrix into submatrix, which is followed in this divide and conquer method. Then, based on this formula, we are calculating the final solution. Here, the one recursive call is reduced, so only P1 to P7, 7 recursive calls operations are done. So the time complexity is reduced here. When calculating using this formula also, we will be getting the same solution only. But in order to reduce the time complexity, we are following this Strasson's method. In calculating, this is a 7 recursive calls, and this for addition of matrices O of n power 2, we will be getting the O of n power 2.8074, which is uh, lesser than the other methods O of n power 3. So in case of Strasson's method, if we consider them for our operations, it is kind of, it has some complexity. We can't do that by hand, like manually. And also in submatrices, this recursion takes extra space. Also, large errors can be accumulated when we use on non-integer values. So that's it for today regarding the divide and conquer approach followed in matrix multiplication. This Strasson's matrix multiplication method. So to this, we can close the session. If